Okay, outlier detection rules. There are two rules to detect outliers in a sample, and outliers are extreme values from a dataset, and these are values that do not satisfy a particular profile. And there are two types of rules. The first one is the Z-score rule, and the second one is the Iqr rule. The Z-score rule is generally more accurate when the sample has a normal distribution, and Iqr rule, on the other hand, is more accurate because it's based on all the statistics, and you don't have an assumption about the distribution. We don't have to assume that the sample is normally distributed. So what are the rules? The Z-score rule makes use of the Z-scores, and if an observation is an outlier, then its Z-score would be either greater than 3 or less than -3. That is the Z-score rule. The Iqr rule, on the other hand, makes use of the Iqr, and an observation is an outlier if the observation itself, not the Z-score, it has to be the observation itself, and the observation is greater than Q3 plus 1.5 Iqr, or the observation is less than Q1 minus 1.5 Iqr. So here Q1 is the first quartile, Q2 is the second quartile, although we are not going to use the second quartile in the Iqr rule, and Q3 is the third quartile. Iqr is the interquartile range. It is Q3 minus Q1. I'll explain the rules using an example. So that is my sample. I have the observations listed up there, and I'd like to know, with respect to the sample, if 17.24 is an outlier, if 22.49 is an outlier, or if 0.595 is an outlier. If you don't know what a Z-score is, the formula for a Z-score is just x minus x bar over s. I actually have another video explaining on how to calculate Z-scores for an observation from a sample, but the formula is the same. It is x minus x bar divided by s, where x is the observation, x bar is the mean, and s is the standard deviation of the sample. So I have the sample over here, and I entered the sample onto a calculator, and I found x bar as 10.02, s is 6.62, first quartile is 3.9, the third quartile is 15.29, and the Iqr Q3 minus Q1 is 15.29 minus 3.9, which would give us 11.39. If you want to know how I found that using a calculator, it's quite straightforward. First, enter the data onto your calculator. That is my data. I've entered it all. Make sure you enter it correctly. After that is done, you can go to Start Over Calc, press 1, state list 1, enter, and to get the mean is the first number, the fourth number is the standard deviation, and if you scroll down you'd find the first quartile, the third quartile, and those are the numbers that I actually have on the main screen. So now let's find the Z-score of 17.24 and determine if 17.24 is an outlier. So 17.24 is my observation minus the mean, which is 10.02, divided by the standard deviation, which is 6.62. 17.24 minus 10.02 is 7.22. Divide that by 6.62, and we'll get a number close to 1. 7.22 divided by 6.62 will result in 1.09. Therefore, the z-score of 17.24 is 1.09. So 3, -3 on the z-score scale. Our observation falls right there, which is 1.09. So if it falls between -3 and +3, then the observation is not an outlier. So according to our rule, the observation falls within -3, within the range between -3 and +3. Therefore, per z-score rule, 17.24 is not an outlier. Now, let's use the Iqr rule. The first quartile is 3.9. It's the first quartile, 3.9, Q1. And the third quartile is 15.29, Q3. Now, the two limits are Q1 minus 1.5 times the IQR, which is going to be a number smaller than Q1, and Q3 plus 1.5 IQR is going to be a number larger than Q3. So I know Q1 is 3.9 and 1.5 times IQR, which is 11.39. 1.5 times 11.39 is possibly around 17. .085, and I'm going to write it as 17.09. So we have 3.9 minus 17.09, and on this side it is Q3, which is 15.29 plus 1.5 times 11.39, which is 15.29 plus 17.09, which is, I believe, 32.38. So if the observation falls on this interval between 3.9 minus 17.09, I forgot to find that one. I believe that is negative 10 point, excuse me, it's more like 14. It's negative 13.19. So negative 13.19 would be the difference between 3.9 and 17.09. Let's just make sure that my mind calculations are correct. They are. So negative 13.19 and 32.38 are the two endpoints that will help us make a decision, and as long as the observation falls in that shaded region between the two numbers, then the observation is not an outlier. In the first problem, the number is 17.24, falls right over that. Therefore, per Iqr rule, um, 17.24 is not an outlier. Please note that the sketch that I drew is not to scale. Don't let it confuse you. 15 is over here, and that is 32.38. And you might wonder, how did 17.24 get there? It's not to scale. I'm just pointing out that 17.24 falls somewhere between 15.29 and 32.38, and it is within the acceptable range of the sample for it to be considered as not an outlier. Okay, now moving on, the second observation that we have in the problem is 22.49. Let's do both the rules. If we use the z-score rule, z is x minus x bar divided by s. The observation is 22.49 minus the mean, which is 10.02, divided by the standard deviation, which is 6.62. 22.49 minus 10.02 is 12.47, divided by 6.62, it's approximately 2, but let's find out the accurate number. 12.47 divided by 6.62 is 1.88. So the z-score of 22.49 is 1.88. So negative 3 and positive 3 for the z-scores, and 1.88 is somewhere over there, and it falls within the acceptable range for an observation to be considered as not an outlier. Therefore, per z-score rule, 22.49 is not an outlier. Now, the second rule is the Iqr rule. We actually don't have to repeat the work again. We actually have all the information needed for the Iqr rule, because I know the endpoints Q1 here, or the first endpoint over there, is Q1 minus 1.5 times Iqr, and Q3 plus 1.5 Iqr on the right, and we know these numbers are negative 13.19 and 32.38. We actually found these values in the previous slides when we did the previous problem. We have this information, so we can just carry it over here, and we can find that the observation 22.49 falls somewhere in the middle, hopefully, or possibly over there, 22.49. So since it falls between these two numbers, per Iqr rule, we can conclude that 22.49 is not an outlier. So, carrying on with the same approach, we'll say that problem C, we had the observation as 0.595, and if we first use the z-score rule, the z-score for 0.595 is x minus x bar over s, so we get 0.595 minus x bar, which is 10.02, divided by 6.62. You could use a calculator to find that number. So 0.595 minus 10.02 divided by 6.62 is negative 1.42. So the z-score is negative 1.42. We know the rule states that as long as the z-score of an observation is between -3 and +3, the observation is not an outlier. So negative 1.42 would fall somewhere over there, it is within the acceptable range. Therefore, we conclude per z-score rule 0.595 is not an outlier. We could do the Iqr rule for the same problem, and we'd find that we have established the limits already. So Q1 minus 1.5 Iqr is negative 13.19. Q3 plus 1.5 Iqr is 32.38. And the observation here is 0.595. It's maybe over there. This is just an approximate, but I know it falls between these two numbers. Therefore, per Iqr rule, 0.595 is not an outlier. Let's do one surprise question. For the same sample. It's an extra question which wasn't there. Is 34.29 an outlier? Well, I think it is. I know it is, because if you use the Iqr rule, we can immediately see that 34.29 does not fall within the range we have established. Q1 minus 1.5 Iqr and Q3 plus 1.5 Iqr. Q1 minus 1.5 Iqr was negative 13.19. Q3 plus 1.5 Iqr is 32.38. And 34.29 falls outside, probably over there. If it's between those 2 points, the observation is not an outlier, but it falls outside, so it lies outside of the acceptable range. I'll just write it as out, because you can connect out and lies, and it's an outlier. So it lies out of the acceptable range, to be precise, right outside of the acceptable range. Therefore, per Iqr rule, 34.29 is an outlier. Now, I use the last problem here, and we can do the same problem using z-score rule. And what answer should we expect? Well, let's say if we get a z-score over 3. So if we use the z-score rule, x is 34.29, x bar is 10.02, standard deviation is 6.62. I'd like to find the z-score, which is x minus x bar over s. So 34.29 minus 10.02 divided by 6.62. 34.29 minus 10.02 is 24.27. Divide that by 6.62. I'm expecting a number close to 4, maybe 3.8. So 24.27 divided by 6.62 is 3.66. So it is 3.66. According to our rule, if it lies between -3 and +3, it is not an outlier. If it lies outside of this range, then it is an outlier. Clearly, the z-score of this observation, 34.29, lies over there, 3.66. So, per z-score rule, 34.29 is an outlier. So those are the two rules commonly used to detect outliers, and as I mentioned, one rule is considered to be more accurate than the other, but if you consider extremely large samples, it really does not make a difference as to which is accurate. But generally speaking, Z-score rule is more accurate for normally distributed data, and Iqr rule is generally more accurate than the Z-score rule. And to summarize, Z-score rule states that an observation is an outlier if its Z-score is greater than 3 or less than -3, while the Iqr rule states that an observation is an outlier if the observation itself is greater than Q3, which is the third quartile, plus 1.5 times the Iqr, or the observation is less than Q1 minus 1.5 times the Iqr. I hope you have some idea about outlier detection rules. Please work on the problem if you have more questions. Thank you.